All right, so section 2 of week 6, Swyk number 1. Do we have a single log? No, we do not. So, what are we going to, what? I wanted to change it to a smaller pen size. There we go. All right, so what are we going to do? We see subtraction inside there. Of course, we're going to divide the 15 and the 8x, right? It's creating a single log. Once we have a single log, we can change it to its exponential form. Base, right? Base is 10 because you don't see anything written there. 10 to the first because that's your exponent on the other side. Logarithm means exponent. 10 to the first equals 15 over 8x. Time for a little cross multiplication, right? 15 times 1 equals 8x times 10. And then we divide by 80 on both sides. Of course, they don't want a fraction. They want a decimal. So 3/16 is the same thing as 0.1875. Yeah, it's like a broken record. I know. We've done that one before. Okay, so we're starting to get into some other ones, some different types here. So let's take a look at here. Do we have a single log? Nope. Okay, so we look here and we see that it's addition. Therefore, we have to multiply the x minus 15 and the x together. That's what creates this new argument, x squared minus 15x. Of course, now we have it as a single log. So, change it to its exponential form. The base, obviously it's 10 because you don't see one written there. The exponent's on the other side, it's a 2. Everybody knows 10 squared is 100. And of course it equals the argument x squared minus 15x. It's a quadratic. How do we solve quadratics that have a linear term in them? Of course we have to put them equal to 0. Do we want to use the quadratic formula? No, we want to use factoring. Could we use the quadratic formula? Yes. You can always use the quadratic formula when you're solving quadratics. But they're going to be nice. So, we've got x squared minus 15x minus 100. What multiplies to negative 100 but adds up to negative 15? So, I found negative 20 and positive 5. Now, we talked a lot about this last semester, so I won't beat this into the ground. Set the factors equal to 0 and solve. Most of you are pretty good at that, and you would find out that we have negative 5 and positive 20, right? All right, now, this is where we have to get into checking our solutions. We talked about it earlier, but now it's time to actually do it. It says, be sure to reject any value of x that is not in the domain of the original logarithmic expression. In other words, plug it back in. I want to focus your attention right here on log x. Log x. Okay, we've already looked at the graph of log x. Here's the graph of log x. It's got a vertical asymptote at x equals 0. It does not cross that line. It gets closer and closer and closer to it, but never touches it. Suddenly, I'm asking you about what's going on over here at negative 5. So what is going on at negative 5 over there on that side of the left side of the x-axis or y-axis? I'm waiting. That's right. I don't know either because there's nothing over there. Okay? We said on all those questions that the domain would go from the vertical asymptote that way. In this case, 0 to infinity, which means that negative 5 is impossible. You can't plug no negative 5 into it. Now, you can plug a 20 in, right? That's over here somewhere. That's okay, but not negative 5. So you'll notice that I crossed it off. I crossed off negative 5. 20 is the only answer to this question. Whew, that was just question 2. Man, got to see if we can pick up the pace here. Okay, so once again, we see addition here. So we're multiplying x plus 4 and x minus 2. I used my handy-dandy box. You don't have to if you don't want to. You can draw the arrows, right? First, outsides, insides, last, all that good stuff. Smiley Sam for those of you who like to make a face out of it. That gives me x squared plus 2x minus 8. Do we have a single log now? Yes, we do. So we can change it to its exponential form. What's the base? It's not 10 this time. It's 2. Got to hold up 2 fingers when you're saying 2. And I was holding up 3. Okay, just because I was trying to hold my stylus. 2. All right, so 2, the exponent's sitting over here on the other side, 4, that's 16, equals the argument x squared plus 2x minus 8. Of course, we're going to subtract the 16 to the right side. Why? Because we got to get it set equal to 0. Now we need to come up with factors of negative 24 that add up to 2, positive 6, and negative 4. And so, yes, you end up with the 2 values, negative 6 and positive 4, right? Set the factors equal to 0 and solve. But we run into that one problem that we just talked about when we plug it back in. When I plug in negative 6 plus 4 or negative 6 minus 2, I'm taking the logarithm of a negative number. Can't happen. Logarithm of a negative number, impossible. But the 4 works just fine, therefore 4 is the only answer to that question. Moving on down the road. Question 4. We see subtraction right here. That means we're going to create a fraction, right? Log base 4 of that fraction. And now that it's a single log, we can change it to its exponential form. The base is 4. The exponent is 2. And it equals the fraction x plus 4 over x minus 11. Remember, anything can be divided by 1. Cross multiply. That's right. Good call. Cross multiplication. So we cross multiplied, right? 16 times x minus 11 and x plus 4 on the other side. Of course, we're going to distribute the 16, which gives me 16x minus 176. And then we start pushing the variables and the constants to the opposite sides. And that gives me 15x on the left and 180 on the right. Little division, we end up with 12. 12 does work, so we can plug it back in. But we get a good answer, so we don't really need, I mean, you can plug it back in. You got 16 over 1. Yeah, that's log base 4 of 16 is 2, right? That's good. That's a good answer. You can double check it if you want, but it does work. Question 5. All right, so... oh, look here. This is interesting. That can be simplified, log base 3 of 9. Using my handy-dandy change of base theorem, I realize that that's the whole number 2. So I can change this to 2 plus 2 on the right, which we know 2 plus 2 is 4. Oh, but then I've got to divide that to the other side. And when I divide that to the other side, I get a nice-looking expression. Is that a single log? Yes, it is. Therefore, we can change it to its exponential form. The base is 3. The exponent is 2. It equals the argument x plus 8. 3 squared is 9, so if you subtract 8, you get 1. That's the answer to your question. It works out. You can plug it back in. You can try it. It will work. Sorry for yawning. Last one for this, Swyk. Sorry for going too long. Just making you practice. This one's actually not too bad, right? Because you see that this side is not a single log, so you're going to put them together. You're going to take the x and the 5, and you're going to multiply them together, creating log 5x equals log of x plus 5. Now, we want to look at this one. This one's a little different. You have a logarithm on both sides with the same base. They are equal according to the sign in between. The bases are the same. That forces the arguments to be the same. So some of you might say, well, did you just drop the logs? Kind of, yeah. Because the arguments have to be identical. The x plus 5 and the 5x have to be equal. And if you subtract and then do the division, you get 5/4. So that's enough for this week. See you next time.